Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. So we have just gone through all the things related to data and we have worked on data. What are the important things that we are having in a data, the EDA part, everything we have completed, and we have moved on to a new thing like we have moved on to the machine learning part where we have explored what are the classifications in machine learning. We have gone through different kinds of algorithm that we are having in machine learning like logistic regression, decision tree. I think we have looked into multiple linear regression and together with the theory part as well as coding part. Okay, hope you guys are enjoying. So we are enjoying a lot and we are learning a lot each and every day. Okay, hope the same thing for you guys. So today is going to be a session like support vector mission. Okay, so guys, as always, if you guys come to this stage, please make sure that you guys all the previous session videos so that this is very easy for you so you can be able to understand what we are talking. Okay, so that's the thing guys. So without wasting any time, let us jump into today's session. So today's session is all about a theoretical concept of support vector machine. Okay, in data science. Let's see what is support vector machine. Okay, so support vector machine are a powerful machine learning technique widely used in various data science applications. They excel at both classification and regression tasks, offering a robust and versatile approach to data analysis. Okay, I will say support vector machine is another algorithm which we're gonna see together with the theory. That's a black box of it, and then together with its coding we're gonna see. Okay, so as we have seen, right, Bayesian tree and then random forest, this support vector also is one of the very key and I will say a good algorithm. Okay, based on the probability thing that it is finding, right? I'm just saying based on that. Okay, so and guys, one more thing, we will be learning like nearly 50 plus algorithms. I will say 45 to 50 plus algorithms. No matter like how much algorithm we learn, whenever data is given to you, you need to decide what is the algorithm going to be useful for the data, and you need to choose that algorithm. Not that you know about like 45 plus algorithm, you need to go for all the algorithms and use. No, based on the your data set, whichever the algorithm is fitted for your data set, you need to use it. Okay, that's a one thing. So yeah, the support vector machine is one of the kind of algorithm that we're gonna discuss. Okay, yes sir, over to you.
Yeah, so guys, we will be going through just a minute. We'll be going through support vector machines today for data science. Okay, so it's a powerful tool. Okay, so it's a powerful tool for machine learning technique widely used for various data science applications. They excel at both classification and regression tasks. Okay, and offering a robust and versatile approach for data analysis. So sport vector machines are SVM, we call it in short term. So it is a very powerful tool, guys. So if you see mathematically, it is just a one or two liner mathematical algorithm, but you have to understand deeply at a meta level that how it functions in the black box. So they are very powerful for machine learning. So they help us for both classification and regression tasks. And it is very robust, it is versatile for data analysis because they can perform on different vectors, okay, different scales. So that is the powerful this. So in like it is not a linear kind of thing. It will work on different positions, okay, with different dimensions. So that is what makes it powerful. So if you have come to this session, so go watch all the sessions 5 to 10 times, do reinforcement learning, keep learning deeply, and subscribe to our channels. Also press the bell icon so that you will get notification for each session, and keep learning deeply with long-term objective function, patience, consistency, and persistency. And give us feedback for these sessions if you like, whatever feedback, so that we can keep continuously improving. Thanks a lot. Keep learning deeply. Let's move to the other section.
Yeah, sure, sir. Let's see what we are having next. Okay, let's see what are the fundamentals of support vector machine. Okay, so yeah, uh, I have said right. Support vector machine is also a mathematical algorithm that gonna perform in a manner so that we will fix a data point and then we can move for the classification or regression task. Okay, let's see what is the fundamentals of support vector machine. As it is core, okay, at its core of SVM, aims to find an optimal hyperplane that best separates different classes of data points. The hyperplane maximizes the margin, the distance between the hyperplane and the closest data point. Those are called as the support vectors. These support vectors plays a crucial role in finding the best or like decision point. Okay, guys, consider a simple thing. Okay, whenever you think about SVM, we will be having a hyperplane that is a straight line. Okay, and we will be having two more lines like belong it. Okay, we will be having a straight line. Left side there is one line and right side there will be one line, and there is a gap between these things. Okay, left side line and a straight line. Okay, the hyperplane, right side line and the hyperplane. So the distance between them makes it two distinct classes. Okay, this is how this SVM works. Okay, so they will be having a hyperplane. Using the hyperplane, they will be classifying the classes. Okay, let's see. So hyperplane, the line of the plane that separates data points into different uh, classes. That is called as hyperplane. Margin, the distance between the hyperplane and the closest data points. Okay, that's it. Okay, left data point and also right data point. That is called as margin. Support vectors, data points closest to the hyperplane. Crucially, those are crucial for determining the direction boundary. Okay, so guys, this is a thing, simple thing. So if you think about support vector, just think of it is having a hyperplane that is a straight line. It gonna divide two different classes. Okay, that's it. So the classes that we are having, right, a data point will be very closer. What data point will be very closer to class A to hyperplane and class B to hyperplane? They are called as a margin and they are the support vectors. The points are called as a support vector, and using those points we will create a one more line in both the sides. Those are called as a margin. Okay, so hope you guys can understand. A simple way to understand is whenever you are having SVM, right, it has a hyperplane. Using that, it will separate the data. That's it. Okay, hope it is very easier to understand. Okay, so yes sir, over to you.
Yeah, so fundamentals of SVM. So, guys, we have to understand that SVM is a very powerful technique, okay? And so, at its core, if you see, SVM aims to find optimal hyperplane, okay? So hyper means multiple, like it's not one dimensional, okay? So the best uh, separates different classes of data points, okay? See, if you are not hyper, like the nature is not hyper, then what will happen? It will not have different data classes of data points. So the hyperplane maximize the margin, that the distance between the hyperplane and it is closest data points, known as support vectors. Okay, the support vectors play a crucial role in the defining the decision boundaries. So that is the definition. So what is hyperplane? The line or a plane that separate data point into different classes. That is what I said earlier. So there are different classes. It's not one linear thing, okay? But it has different separate data points into different classes, and that's what is the main nature of SVM. Then you have margins, the distance between the hyperplane and the closest data point. That is the margin. So what is the margin between different um, hyperplanes and the closest data point? That is what is margin. Okay. So you know the definition of margin. Okay. And so margin is always the, you can say, the freedom between two different things, right? So that when we say when you're running, when you're driving a car on a road, so always keep that margin of 1 or 2 feet from the other car. Okay, when you because that margin will save you, like when you have to take cut, or when you have to move here and there. If you don't have margin, you will collide. Similarly, if the classes don't have margin between them, then that would be a one class. So that is why margin is very, very important in the hyperplanes. Okay, so that is the closest data points between hyperplanes. Okay, distance, the same thing. When I gave example of a car, same thing is with the data points, guys. Okay, so support vectors. So support vectors are data points closest to the hyperplane. Okay, now you have to understand what is support vectors. They are closest to the hyperplane, crucial for determining the decision boundary. Okay, like it's a very thin line which you have to understand. So hyperplane has a different definition. Support vectors are different. Margin is different. With this SVMs, we make SVMs. So these are the fundamentals with which SVM is made: hyperplane, margin, and support vectors. Okay, so you have to distinct each element from other, so that you don't have confusion and you clearly understand. So again, I will reiterate so that confusion is clear, because a lot of people get confused, or they think it is rocket science. So hyperplane is a line or a plane that separates data points into different classes. That is what is hyperplane. Okay. So margin is the distance between hyperplane and the closest data point. That is what you have to. That is the distance between hyperplane and the closest data points. Then support vectors are the data points closest to the hyperplane, crucial for determining the decision boundaries. Okay, so this is very, very important, guys, because I told you, if you understand what and why, how you will understand, that's a 10% thing. 90% is what and why, because there your ideas for application get super clear, so that you can apply with speed of light. But when your ideas are not clear, your concepts are not clear, you cannot apply those ideas with speed of light. Okay, you can't be fast in application. So you've seen a lot of people, they are very fast in application and they are good at getting outcomes, because they have understood the magic that what and why is super crucial. If you understood at a meta level deeply what and why, application is nothing, that is 10%. So here, when we are discussing the concepts like fundamentals of SVM, you have to understand these concepts deeply, so that when we go and apply, that's nothing. Because you know what is margin, what is hyperplane, what is support vector, and what is the fundamental nature of a SVM. When you know that, you know limitation, what it can do, what it can't do, then and only you will go with clarity. In seconds, you're going to apply. You just need to apply in a library. Right? Everything is written. The main thing is what and why. How will that will happen naturally at the speed of light. So keep learning deeply, guys, with long-term objective function, and build your vision for long-term careers and skill set, and become a lifelong learner. Thanks. Let's move to the other section.
Yeah, sure, sir. So moving on, let's see. So we have just discussed about the fundamentals of SVM. Now let's see. SVM for classification. Okay, we have mentioned classification and also regression, this SVM support. Let's see how it is working for classification. SVM is especially that is it is effective for classification tasks where the goal is to categorize data points into distinct classes by maximizing the margin. I hope like now you guys know what is margin. SVM creates a robust and accurate decision boundary, that is a hyperplane, capable of handling complex and non-linear data set also. Okay, that's a major thing. So it is not that it should be a like linear. Okay, we can have a data set in a non-linear format, like it can be a circle kind of thing or star kind of thing, eclipse kind of thing, anything. Okay, it is able to classify because it has something called as a kernel, and we can tweak the kernel. Okay, what kind of thing that we need, whether we need a linear kernel, non-linear kernel, we can fix it. Okay, let's see what are the types. Binary classification, SVM can effectively classify data into two distinct classes. Binary, you know, right? Binary. So binary, bi means two, right? So that's the thing. So we can use this SVM to classify two different classes. Multi-class classification is can be extended to handle multiple classes, uh, technique, like one versus one or one versus rest strategies. Okay, yeah, the thing is we can use this SVM for classifying two different classes or more than two distinct classes. Okay, that's it. Okay, so yeah, this is what all about SVM for classification. Yeah, sir, over to you.
Yeah, SVM for classification. So here we'll just focus on classification, guys. Don't think anything else. Only as per the objective, what we have to define. Okay. So we'll only talk about SVM for classification. Okay. So other thoughts you have to keep in control. SVM exceptionally effective for classification tasks. Okay. Okay, so where the goal is to categorize data points into distinct classes. Okay, so if you see classification, it has come from class. The the parent of this particular word is what we call uh, etymology. What is the from where this particular thing has come? Okay, so it has come from class. So that means so SVM naturally it is for classification, which distincts the different data points in different classes. That's it. Now we have understood in fundamentals, three aspects are very important in SVM, the fundamental units. One is that we have to, it will margin is there, okay. Then you have, we have discussed the the other points we have discussed. Okay, margin is there, yeah, hyperplane is there, okay, and then you have what you call is the other point was which the point was Raja,
Support
what was
vectors. Yeah,
huh?
support vectors.
Support
Support
vectors.
vectors. Yeah.
Okay, so that is the fundamental. So I'm saying that the basic elements were these three. So with which SVM we make the SVM, right? So uh, so here SVM by maximizing the margin, SVM creates a robust, accurate decision boundaries, which we know in SVM that is the main thing. It creates robust, accurate decision boundaries. Okay, so that it makes decision, guys. That is why. So that is why SVMs are very powerful, capable of handling complex and non-linear data sets. As I said, when you say support vector machines, they are actually for non-linear and complex data set. That's why, because they have different hyperplanes and different classes. It's not for linear data sets, right? So that is why, because it will have different classes. So this is the nature, okay? So when we talk about SVM for classification, okay? So then binary classification, SVM can be effectively classify, it can effectively classify data into two distinct classes. Or like when it does in two, that's binary, but when it will do more than two, then that will be multi-class classification. That's what, because binary is what? Bi means two, okay? So that is what, uh, if you understand the basic nature of a particular word. Okay, so SVM can be extended to handle multiple classes using techniques like one versus one or one versus rest strategies. And that's it. It's very basic, guys. Basic English. Just understand the main essence of the definition. Don't remember everything. Just understand, reinforce, absorb 5 to 10 times. When I'm saying 5 to 10 times, it will enter not your mind and soul, but in your entire consciousness. So once, and don't put everything in your consciousness, just understand the main essence of a definition of a concept. So binary classification, when somebody asks, so you know what is classification? Making two distinct classes. Okay, binary means two different, bi means two. So SVM can effectively classify data into two distinct classes. This is how you remember. Okay, when somebody asks what, or you are going for application, so if you forget, still you will remember. If somebody will ask in SVM what is, how we what are the main aspects for classification, you can say there is binary and multi-class. So binary is for two, multi is for one versus one or one versus rest of the strategies. This is how you don't have to remember everything, just the main essence of the concept. And that will make you powerful. Because, see, ultimately, we also have a memory, guys. We can't put everything in our memory. So, a lot of people, why they are not good at concepts and understanding things? Because they put everything in the memory, and memory gets full. Human memory also has limitation, guys. So it gets full, then you don't remember rest of the things. So that becomes a problem. So it's a memory problem which creates issues for intelligence, for humans. So we have to optimize our memory, human memory, remembering the essence of the concept. This is very deep, guys, now, because nobody will tell you this. Okay, you have to remember the essence of the concept, not the entire concept. Or when you go for reading any book, just don't read and remember all the book. Just understand the main aspect which you don't know. Rest, whatever you know, why you have to remember that? You know that. Whatever you don't, out of that, the actual essence. And when you have that, and try to understand that the every question has an architect answer 80% in it. So you need to have a strategy. Whenever you see certain words, you should get, memory should be in the question, not in your mind. The consciousness you put on the words. So whenever I see binary, I'll know it is bi. Bi means two, nary means two digits, right? Classification, whenever I see classification, I'll see, oh, classification from class. So that means it will be two distinct classes. So this is how, so I'm giving you science of how you can understand the essence of concepts, guys. It is beyond education. You will not find it on YouTube or anywhere or any, because people don't understand these things. Knowledge of knowledge. This is what I am discussing. So how you can acquire deeply the knowledge and understand the concept deeply. So this is one time I am giving. So apply these concepts for all the rest of the sessions, because here we are discussing. Uh, we don't have much time to discuss all these times things every time, but right now, so that you understand these things properly. Let's move to the other section.
Yeah, sure, sir. Okay. So this is what all about SVM for classification. Let's move on. Next, we're gonna see regression. Yeah, that's it. So SVM for regression. So SVM can also be used for regression, as we've discussed before. It will be used for both classification and regression, where the goal is to predict the continuous target. Okay, guys, I hope you know, when we need to predict the categorical value, then we need to go for classification. When we need to predict the continuous value, we need to go for regression. Okay, So it is used to predict the continuous target variable based on the input features. The SVM algorithm finds the optimal hyperplane that minimize the error between the predicted and the actual value. That's it. Okay. Yeah. First is data transformation. The input data is first transformed into a high dimensional space using kernel function. As I mentioned, right? So whenever you are having a data in some format, it tries to map it to the high dimension. That's the first thing. Then hyperplane optimization. The SVM algorithm then finds the optimal hyperplane that minimizes the error between the predicted and actual results. Once we have we have ported or we have just make our data to the high dimension, it then we will train the model, and the hyper optimization, what it does means, it tries to minimize the error between the actual result and the model predicted result. Then prediction. Once the hyperplane is determined, it can be now used to predict the target variables for a new data points. Okay, so once everything is done, we will go for unseen data and we will predict its what is the continuous value we need to have. Putting in a simple form, we will be having our data, we will pushing our data to high dimension, then we will find our optimal hyperplane in order to perform the regression. Once everything done, training is done, then our model is ready, then our model is ready to predict on the unseen data, and we will go for what is a continuous value for it. Okay, hope everything clear. I think it's a simple explanation. Okay, so yes sir, over to you.
Yes, so SVMs for regression. We have talked about classification. Now let's talk SVMs for regression. So we always know what is SVM. We know now what is SVM, support vector machines. Okay, they are very powerful for classification. And now let's understand they're powerful for regression. Regression, you know what it is. It is regressing till you reach to the optimal outcome. We have to regress again and again, huh? So reach the optimal outcome for the particular. So SVMs can also be used for regression problems where the goal is to predict a continuous target variable based on input feature. Okay, on input feature, an SVM algorithm can find optimal hyperplane, okay, that minimize the error between the predicted and actual value. So that is what, see, when we talked about SVMs made up of margins, SVMs, the fundamental elements of it, and the hyperplane. So that is because the main essence here lies when SVM, see, the SVM algorithm finds the optimal hyperplane that minimizes the error between predicted and actual, because predicted will be a separate class, actual will be a separate class, and there the margin plays a role because it will keep distance between distance, there would be a distance between those data points. That is why that is the main element of a SVM. Okay, so data transformation, these are the elements. Let's go for three elements for the regression. So first is the input data is first transformed into higher dimensional space using kernel functions. Okay, so you guys know what is kernel. Okay, if you don't know, write in the comment section what is kernel, because you need to know each and every meaning of definition of the word, so that in context of AI, ML, and data science, so that you understand properly what we are saying, what we are talking. Okay, so then you'll have idea. So again, I'll reiterate, the input data is the first transform into the higher dimension. First, it will go higher dimension space using kernel function. That is the data transformation nature, guys, in regression SVM. Okay, then hyperplane optimization, SVM algorithm then finds the optimal hyperplane, okay, that minimize the error between predicted and actual. That is very important, because it will it finds the optimal hyperplane that minimizes, okay, the error between predicted and actual. Okay, that is why the performance will be there, right? Because when you're not minimizing the error, then it uh, there would be a problem. So then once the hyperplane prediction, what is the prediction? So once the hyperplane is determined, it can be used to predict the target variable for a new data point. So that then happens the prediction in regression when we use SVM. So once the hyperplane is determined, it can be used to predict the target variable for new data point, because once we have done transformation in regression, SVM for regression, so once we did the transformation, then it will do hyperplane optimization, then prediction will happen. So there is a sequential chronology. Okay, so this is how SVM for regression will actually conceptually what and why will happen, but then you will see mathematics of it and then application. So this is how SVM for regression behaves. Okay, so let's move to the other section. Thanks.
Yeah, sure, sir. So yeah, guys, like we will pass here. Okay, the thing is, we have introduced you what is SVM, what are the key concepts present in SVM, and how SVM works for classification and then regression. Okay, so we will pass here. I hope like this session is very insightful to know about what is SVM, mostly support vector mission, how it will be acting for two different problems. Okay, so hope you guys have enjoyed. We have enjoyed a lot, and we will continue this session tomorrow. So take care, guys. Bye. Until next session. We all meet in the next session. Okay, until then, bye guys, take care.
Yes, so guys, remember, do reinforced learning. Go watch all the session 5 to 10 times and apply the information, absorb the information, apply the, digest the information and apply the information. Okay, and have a long-term objective function and a greater vision for your learning so that you will keep learning continuously every day without getting a degree or any confirmation or recognition. Just continuously keep learning so that you would build excellence body, knowledge body, and keep learning and subscribe to our channels. Also, press the bell icon so that you will get notification for each session, guys. And write in the comment section if you have any feedback. So we will always keep improving these sessions. So thanks a lot. Keep learning.